So hopefully by now you come to realize or know that the derivative of the sine of x is the cosine of x. But the proof, it's a little more complicated than that. We usually take it for granted. We just say, oh, well, the derivative of the sine is the cosine of x, and we move on. But how do you actually prove it? Well, for that, we have to go back to the definition of the derivative and then use a trig substitution, namely that the sine of the sum of two angles, sine of A plus B, equals the sine of A sine B plus cosine A cosine B. And so here we start by substitution. We assume that f of x is the sine of x, f of x equals the sine of x, and we substitute it into this definition. So that gives us that the limit as delta x goes to 0 of the sine of x plus delta x minus the sine of x, everything divided by delta x, where, as we remember, delta x is some small infinitesimal differential amount. And continuing from there, we say that the limit as delta x goes to 0 equals, here we would need to substitute the expression above here, or rather equation number 1 over there. So we write the sine of x cosine delta x plus cosine x sine delta x minus, just like up here, the sine of x, and everything again divided by delta x. And then we break our fraction here into two separate fractions. Namely, we can break up the sine of x times the cosine of delta x minus 1 over delta x plus cosine of x sine of delta x over delta x. And the reason we do that is because we have to use these definitions, or actually these theorems that we have here. Now these two theorems, which are proved in limits section, says that the limit as delta x goes to 0 of 1 minus the cosine of delta x over delta x is indeed equal to 0. Now that can be proved at in the section of limits. The same with the limit as delta x goes to 0, there should be a 0 here, of sine of delta x over delta x is equal to 1. This, some books call it the squeeze theorem, but we substitute those into here. So we are here, we separate this a little bit, factor out the sine of x. Over here we will factor out the cosine, the limit of the cosine of x as delta x goes to 0, and apply the theorems here and here. This gives us 0, whereas this gives us 1. Now if we substitute everything back into here, we would get that this being 0, there is a negative right here, by the way. The negative of 0 times sine of x, by the way, there is no such thing as a negative 0, but the negative remains there, times the sine of x plus the cosine of x. By the way, the limit as delta x goes to 0 of the cosine of x is just cosine of x, because there's no delta x here. However, the limit as sine delta x over delta x, that becomes a 1 from our definition above. So here's their substitution, and then this simplified, this goes to 0, this whole thing goes to 0, which gives us a cosine of x times 1, which is simplified to cosine of x. Now you're probably wondering, well, how do you prove that cosine of x is the negative of the sine of x? you can also prove that. So you can say the f prime of, I'm sorry, let me go back here 1 second. We can say that the derivative of the cosine of x is actually minus the sine of x. And the proof is very similar. In fact, you use almost the same expressions, and you can prove this on your own. But now you have the freedom to use these two expressions to find other derivatives. For example, if I have something like f of x equals x squared times the sine of x, then we can apply the product rule here. We can say, well, in this case, f prime of x equals the derivative of the first function, which is going to be 2x times the sine of x, plus x squared times the derivative of the sine of x, which we already know from the previous example here, which is the cosine of x, which then becomes just 2x sine of x plus x squared cosine x.